let's talk about y and the theory behind this. So in any right triangle, actually, let's start with this. Your vector can be in any direction. So I'm just going to use this plane here. So my vector can be in this direction, this one, this one, this one, and we can go through all the different scenarios. But there are a few cases where you have a vector that is pointing directly north, or directly in the vertical direction, or in the horizontal direction. So either one of those. And in those cases, notice it will not have an x component for this vertical one, or it's not going to have a y component if it's directly flat. So that means the component of that vector would be the vector magnitude itself. Okay, so if you want to test that out, if you want to think about that in terms of angle, think about it, you're going to have some angle that's going to be between 0 degrees and 90 degrees. And we're talking about the extreme cases, 0 degrees and 90 degrees over here. Okay, and in those cases, you're not going to have a y or an x component, which means your whole vector's magnitude will be in that direction. So if we took our previous case, 75 newtons, and it was just east, then it will just be, the component east will be just 75 newtons. So in that case, a vector's component is equal to the magnitude of the original vector. So east, that is the x component. Okay, so it's equal. It can be equal. Okay, equal, yes, check. All right, but can it ever be larger? Well then, let's take maybe one of these arrows in between, these vectors in between. So maybe take this one per se. It's going to be messy. Let's use this color. So let's take this guy over here. Okay, let's draw this triangle. We got a right side triangle, and we have the original vector. Keep in mind, that's our hypotenuse, right, of our right triangle. We have our adjacent side, the opposite side, relative to this angle over here. Now here's the thing about your right triangle. Can any side of a right triangle be larger than hypotenuse? No, it cannot. You are right. It cannot be larger. So that in a right triangle, your hypotenuse is the largest side, meaning there cannot be any side or component of your right triangle that's going to be larger. A way to check that, or if you think about even the Pythagoras theorem says just that. You need the sum of the squares of the both sides to give you the square of the hypotenuse. Another way you can think about this is check the sine and the cosine of these angles in between 0 and 90, okay? And if we just want to verify this, notice that what I mean by that is, notice every time you're taking the original magnitude of your vector and you're multiplying by some sine or some cosine of a value, okay? You can check the rest, they're all the same thing. So you're multiplying, so you're taking the original vector and you're multiplying by sine theta or cosine theta, okay? And in order to get a larger number than the original magnitude is to multiply by a number that is greater than 1. So let's check cosine theta, sine theta from 0 degrees to 90 degrees. Let's see if we get any number that's going to be greater than 1. Let's check the extremities first. Let's check sine of 0. Sine of 0, notice we get 0. Okay, sine 0, you get 0. Okay, let's all write these all out. Cosine of 0. Okay, sine of 90. Cosine of 90. Okay, let's check all of these. All right, cosine of 0, that gives us 1. Sine of 90, and I'll do this both together so we don't waste time here. Sine of 90, we get 1. Cosine of 90, we get 0. Ooh, look at that. This is the flip. Interesting, hey? I don't expect you have learned about the sine and the cosine functions on the graph yet. But if you have, you know exactly what I'm talking about. So we know that, so sine theta, sine of 0, 9, we get 0 and 1s basically. No numbers here are larger than 1. But let's check a number in between. I'm going to do, say, 45. Sine 45, cosine 45. Let's see what we get. Okay, so cosine 45. Oh, hey, look, this number is smaller than 1. Sine of 45. Hey, it's the same number. Well, surprise, surprise. Okay, maybe we should try something like 30 degrees. Or maybe, how about let's do 60 degrees, all right? 60 degrees. Cosine 60 degrees, we get 0.5. Sine of 60, we get 0.866. None of these numbers are greater than 1, okay? So I'm just going to write over here, all less than 1. Okay, in between, they're all less than 1. You don't believe me? Try yourself. Okay, if you have a free time to do that, please try yourself. Okay, so fine. So notice if you have a number that is less than 1 and you multiply that by the original vector itself, which in our last case, I don't know, 75 degrees, 75 newtons, okay? You multiply any number less than 1, you're going to get a number that is less than 75 newtons. Oh, so that means your components can never, ever be larger than the magnitude of the original vector. They can be equal, but they cannot be larger, okay? They cannot be larger. Let's use red pen. Can never be larger. Okay, so if you said no to this question, you are right. Cannot be larger. However, it can be equal, though. Equal is still an option. And that just means that your vector is just pointing vertical or horizontal. Phew, that was a long explanation. Thank you for getting through this particular inquiry with me in this video. Hopefully, it has given you some insight into vectors and their components. Good luck with the rest of your practices and exercises. Fat Mama Physics signing out.